The height, h, in feet from the ground of a falling rock t seconds after being dropped from a 50-foot cliff is given by the equation h is equal to negative 16 t squared plus 50. Exercise A asks us, how high above the ground is the rock after 1.5 seconds? 1.5 seconds, that's a value for t, right? T seconds. All right, so this is saying let t equal 1.5, find h. All right, so h would equal negative 16 by 1.5 squared plus 50. So that is negative 16. Well, we can just use a calculator for the. Let's bring up the calculator, and I'm just going to put in that whole expression on the right-hand side. That's negative 16 quantity 1.5 close quantity raised to the second power, and then add 50, and we'll hit enter, and that's 14. So h equals 14. Conclusion, after 1.5 seconds, the height of the rock is 14 feet. Exercise B. How long will it take for the rock to fall to 10 feet above the ground? Round the answer to 2 decimal places if necessary. Alright, so let's see. It's going to fall to 10 feet above the ground, so we're going to let h equal 10. How long will it take? We need to find t. Alright, so then we'd have 10 is equal to negative 16 t squared plus 50. Now, this is a quadratic equation in t, but we're not going to solve it by factoring. In fact, factoring would be very difficult to use to solve this equation. So instead what I'm going to do is, since this equation only has this t square quantity, and there is no t term, we're going to isolate that t square and use a property to then solve for t. So let's first isolate the t square. I'll subtract 50 from both sides. Negative 40 is equal to negative 16t squared. I'll divide through by negative 16. So negative divided by negative is positive, and 40 divided by 16, I'll just go ahead and use a decimal here, 2.5. So we then have 2.5 is equal to t squared. Alright, so now I'm going to use a property of algebra. I'm going to use what's called the square root property. Which states, if x squared is equal to a, then x is equal to the square root of a, or x is equal to the negative square root of a. And that's often written as x is equal to plus or minus square root of a. So, taking that from there, if t squared is equal to 2.5, then t is equal to the positive or negative square root of 2.5. Now, on our calculator, the square root of 2.5 is approximately 1.58. So t is positive or negative 1.58. Now we need to think about this a little bit. Can the ball or the rock be at a height of 10 feet after a positive 1.58 and negative 1.58 seconds? The negative just doesn't make sense here. So we'll throw it away, and our conclusion would be the rock is at a height of 10 feet after approximately 1.58 seconds. Exercise C asks us, how long will it take for the rock to hit the ground? And we're told to round the answer to 2 decimal places if necessary. We generally take the height of the ground to be 0. So we'll let h equal 0 and again solve for t. So then we need to solve. 0 is equal to negative 16t squared plus 50. Again, I have a quadratic equation with just a t squared term and no linear t term. So I'm going to use the square root property again, but first I need to isolate that t square. I will subtract 50 from both sides. So negative 50 is equal to negative 16t squared. I'll divide through by negative 16. Let me calculate that. 50 over 16 is 3.125. So then t squared is equal to 3.125. Using the square root property, I can now write then that t is the positive or negative square root of 3.125. And calculating the square root of 3.125, to 2 decimal places, that's 1.77. So t is approximately plus or minus 1.77. Now again, we have to think about this a little bit. Can the ball hit the ground, the rock hit the ground in a negative amount of time? And again, it cannot, so we will throw that solution away and only accept the positive value. And so what we would say then is that the rock hits the ground after approximately 1.77 seconds.